A study was done about violence against prostitutes and the symptoms of the post-traumatic stress that they developed. The age range of the prostitutes was 14 to 61. The mean age was 30.9 years with a standard deviation of 9 years. So the age range is 14 to 61. The mean age was 30.9. And the standard deviation was 9 years. A, in a sample of 25 prostitutes, what's the probability that the mean age of the prostitutes is less than 35? So the probability that it's less than 35. So we are looking to find this, and we are going to use normal CDF. So normal CDF, our upper limit is 35. Our lower limit is negative E99. Our mean is 30.9. And our standard deviation is not 9 years because this is a sample, so it's, if you recall, it's 9 divided by the square root of the sample size. Let me rewrite this over here. So this would be 9 divided by the square root of 25. Okay. So when we put that in our calculator, we get an answer of 0.9886. So there is a 98.86 probability that the mean age of the prostitutes is less than 35 for a sample of 25 prostitutes. B, is it likely that the mean age of the sample group could be more than 50 years? Interpret the results. So let's find what it would look like if the sample was greater than 50 years. So we're going to do the normal CDF. 50 is going to be our lower level. E99 is our upper. 30.9 is our mean. And if we calculate the 9 divided by the square root of 25, it's 1.8. So I'm just going to substitute that in there. When you put that in your calculator, it's approximately 0. So when they say interpret the results, so what this means is that it's practically impossible for the average age of this group of prostitutes to be more than 50. However, it should be noted that it's still possible for an individual in the group to have an age that's over 50. C, in a sample of 49 prostitutes, what is the probability that the sum of the ages is no less than 1600? So we would write this, what's the probability the sum of x is greater than or equal to 1600? So we'll do normal CDF. The lower level is 1600. That's the lowest it can be, all the way up to E99. Now we have to do some calculations for our mean first. We know that the mean or the sum is n times mu, which is 49 times 30.9, and 49 times 30.9 is 1514.1. Then we also have to calculate the standard deviation. So the standard deviation for the sums of x is the square root of n times standard deviation. So the square root of 49 times 9, 3. Now that we have that, put our values in here. We get 0.086, let's say 4. So in a sample of 49 prostitutes, the probability that the sum of the ages is no less than 1,600 is 8.64%. D. Is it likely that the sum of the ages of the 49 prostitutes is at most 1,595? Interpret the result. So the probability that the sums of the ages of the 49 prostitutes is less than or equal to 1,595. So we are going to do the normal CDF. Now our lower value is negative E99. Our upper value then is 1595. We've already got our mean from up here, 1514.1, and 63 for the standard deviation. We put that in and we get, which is 90.05%. Okay, interpret the results. So we get 90.05%. This means that there's basically a 90% chance that the sum of the ages for this small sample of 49 prostitutes is at most 1,595. E says, find the 95th percentile of the sample mean age of 65 prostitutes. Interpret the results. All right, so if we are finding the 95th percentile, then we're doing the inverse norm of 0.95, and our mean is 30.9. Now I've stopped here because when we are taking the sample mean of 65 prostitutes, we have to figure out what the standard deviation is. So it's this divided by the square root of n. So we have to do that for 65 prostitutes. So 9 divided by the square root of 65 is 1.12. So don't forget to do that with the inverse norm. If you had just come up and pulled this, it would be the wrong answer. Just remember that you have to double check it for each problem and make sure that you've got the right mean, the right standard deviation for the specific problem that you have. So this is 32.7, and when we interpret this, what this means is that 95% of those prostitutes in a 65 of the 65 that you pulled are younger than 32.7 years. So this F says find the 90th percentile for the sum of the ages of 65 prostitutes. So here we're doing the sum. So the 90th percentile, we're going to do the inverse norm of 0.9, but we have to figure out what these values are first. So we know, if you recall, that the mean of the sum of x is n times mu. N is 65 times 30.9, which is 2008.5, okay? And then our standard deviation for the sum of the x's is the square root of n times the standard deviation, so the square root of 65 times 9, 72.5. Also, just a note here, when you put this in, I want the square root of 55, that alone, times 9. I don't want the calculator to take the square root of 65 times 9 together. So I closed my parentheses after the 65. So just be aware of that. So we get 72.56. So we can put these values in up here. You can go ahead and enter this into your calculator. And when you do that, you get 2101.5. So what this tells us is that 90% of the prostitutes in this sample of 65 that the sum of their ages is less than 2,101.5 years.